Hi, today we're going to learn about complex numbers, and this section is under college algebra review, so this is perfect if you want to take the math placement test and you need some study guide. This is where you go. So we're going to do complex numbers. So the first problem says the square root of negative 16 minus 4 times square root of negative 9. So complex numbers. So we're going to have to deal with imaginary numbers, so you can never have a negative inside the square root. So what you have to do is whenever you have a negative, you just factor out an I, because you can't have a negative in the square root. So I'm going to rewrite this as I times square root of 16, because we can't have a negative. So that negative is just an I, minus 4I square root of 9. Right, because you can't have a negative. So let's simplify. So square root of square root of 16 is 4, and then you have to multiply that by I, so that'd be 4I. The same thing with here. So you have a square root of square root of 9 is 3, but make sure you have to multiply it by this whole thing, negative 4. So 4 times negative 4I is negative 12I. And then it's all just combining like terms. So you have 4I minus 13I, and that gives you negative 8I. So that's your final answer. And then I'm going to clear the board. Okay, next problem. So we have negative square root of 16 times square root of negative 9. So like the last problem, we can't have a negative inside the square root, so this should be let's simplify this negative. Since the negative's outside, it's just square root of 16 is 4, but times it by a negative, so it's negative 4. And then the square root of, we can rewrite that as square root of I times 9, square root of 9, so because you can't have a negative. So what's the square root of 9 is 3 times by I, so that's 3I. Sorry, I wrote the problem incorrectly here. It should be negative 16 times square root of negative 9. Sorry, I didn't write the problem correctly. So the square root of 16, let's factor out an I, because you can't have a negative inside the square root. Okay, so the square root of 16 is 4, times by I is 4I. And then I'm going to times it by square root of 9 is 3, times by I, which is 3I. Okay, so you have 4I times 3I, which is 12I squared, because don't forget the I. So whenever just remember this rule. So whenever you have an I square, that should equal negative 1. So remember this rule, I squared equals negative 1. So we have an I square, so it should equal to negative 1. So it's 12 times negative 1, because I squared equals negative 1. So 12 times negative 1 is negative 12. And that should be your final answer. Number 3. So you have square root of negative 16 over square root of negative 9. So I could simplify this as I square root of 16, I square root of 9. So we know the square root of 16 is 4I. square root of 9 is 3, times it by I, which is 3I. And then our I cancels. So we're just left with positive 4 over 3. See, these aren't too hard, so you just really have to remember that I square equals negative 1. Number 4. This is 4 times negative 3I times 4 plus 3I. Okay, so right here, I'm looking at it and it looks like I'm not going to FOIL it. You know why? Because this is a rule we know. This 4 minus 3I plus 4 plus 3I is also known as the perfect square. So if you don't know the perfect square, I don't want to FOIL it because it's going to take too long. So basically the perfect square is this, right? This should be all a review. But I always want to make sure you understand what I'm doing. So, okay, so this is the perfect square. So all we need to know is our A and our B. So we can say our A is 4 and our B is 3I, right? So this part is this part, so we could just have to make it on the right side. So we just need to do A squared minus B squared. So what is A squared? 16 minus, and then we know our B is 3I, so B squared is 3I times 3I, which is 9I squared. Okay, so we remember that I squared equals negative 1, so let's simplify it. So 16 minus 9, and then I squared is negative 1. So 16 minus 9 times 1 is, so these two negatives becomes a positive. So 16 plus 9 is 25. And that's your final answer. Number 5. We have 4 minus 3I squared. So I will not factor this because I'm going to use one of the rules we know. So I know this is a perfect square trinomial. Perfect square trinomial. So if you don't know what that is, you can it's basically this, A minus B square equals A square minus 2AB plus B square. So we just gotta find, okay, so we know this looks like this. So our answer is gonna be in this form. So we gotta just figure out our A and our B. So our A is 4, right? And our B is 3I. Because I'm looking at this part. It's not negative 3I, it's just positive 3I. So now we know our A and B, so we put it in this form. So A squared is 16, because 4 squared is 16, minus, what is 2 times AB? So 4 times 3I is 12I, and times by 2 is 24I, plus B squared, which is 9I squared. So let's clean this up. And we know I squared is just negative 1, so 9 times negative 1. So that's negative 9. 16 minus 9 minus 24I. So let's clean it up. I'm gonna put the numbers first and then the i's second because we want it in this form, A plus BI form. So 16 minus 9 is 7. And then you're just left with negative 24I. That is your final answer. Number 6 is, this one's a weird one, so it's I to the 25th. I know this looks really confusing, but let's start with what we know. So we know that I squared is -1, and we know 25 is an odd number, right? How can we write I to the 25? We can rewrite it as I times I to the 24th, right? Because when you're multiplying exponents, you're really adding. This has an invisible 1, so 24 plus 1 is 25. And we can also rewrite that as I times I squared, which is good because we know what I squared is -1, to the 12th power, right? Because now what we're doing is we're raising it to the 12th power. So when you're raising it, you have to multiply the exponent. So it's like 12 times 2 is 24, and then times it by I, which is I25. The reason why I'm putting it this way because I want to put it into something that we know, and we know that I squared is -1. So this is going to make it more simpler. So we can write it as I times I squared is -1 to the 12th. Okay, so we know that 12 is an even number, so -1 to the 12th is always going to be positive, right? Because it's an even. So -1 to the 12th is just 1. And then you times it by I. So what do you think your final answer is to be? Your final answer is going to be just regular I. So yeah, I just broke it up into things that I know of. So I could rewrite it as I times I to the 24th, and then I can rewrite it as I squared times 12 times I, and then we know that I squared is -1. And then the last one, number 7. We have 3 minus 2i times it by 4 plus 5i. So this looks kind of weird, but it's not hard. But we have to do is multiply the conjugate of the denominator. So let's look at the denominator. We have a 4 plus 5i. So what would be the conjugate of that? That would be 4 minus 5i, because it's always opposite. So you just multiply the denominator and the numerator by the conjugate of 4 plus 5i. So we said that the conjugate of 4 plus 5i is 4 minus 5i. And do it top and bottom, so 4 minus 5i. Okay, so let's simplify this. Let's look at the numerator. So we have a 3 minus 2i times 4 minus 5i. We can't, it's not any special rule, so I'm going to just write it, and then later on I will FOIL it, because it's not one of our special rules. Okay, now let's look at the denominator. We have a 4 plus 5i minus, 4 plus 5i times 4 minus 5i. What does this look like? This looks like the perfect square. So I don't need to FOIL this. I know that the perfect square is a squared minus b squared, right? So we know that our a is 4 and our b is 5i. So let's do it. Let's put it in the a squared minus b squared. So what is a squared? 4 times square. 4 squared is 16. Minus, what is our b squared? Which is, we said our b is 5i, so b squared would be 25i squared. So we can simplify it even more. So 16 minus 25, and we know that I squared is -1. So the numerator is 16 minus a -25, and 16 plus 25 is 41. Okay, let's clean this up a little bit. So we haven't touched the numerator, right? So it's just 3 minus 2i, 4 minus 5i. And then we said the denominator is 41. So we've simplified the denominator as much as possible. Now let's do the numerator. So we agreed that there's no special rule for this. It's not the perfect square, it's not the perfect square trinomial, right? So if in that case we just gotta do simple foiling. So it's like saying 3 times 4 is 12. 3 times negative 5i is negative 15i. And then negative 2i times 4 is negative 8i. And then negative 2i times negative 5i is positive 10i squared. Right, because we're multiplying the i's. Okay, let's simplify so we know. What is negative 15i minus 18i? You could think of it as the I as x, so you could think of it as negative 15x minus 8x. So what would that be? That would be hold on, negative 15 minus 8 is negative 23i. Plus, and then 10, we know that I squared is negative 1, so 10 times negative 1. All over 41. I'm going to put it on the left, so 10, okay, so let's do 12 plus 10 minus 9. So it should be 12 minus 10, because 10 times negative 1 is negative 10, and then minus 23i. So let's simplify it. So that would be, what is 12 minus 10? 2. And then remember we want it in a plus bi form. So we just have a negative 23i. Divided by 41, because that's our denominator. So this should be your final answer. And that's it for the complex section, complex numbers.